thank you for coming out tonight to the museum on this very wet day. It seems somewhat appropriate that we were drenched on our way in the door, doesn't it? We talk about water as a resource and a right, but in reality, water is much more. It is the planet's greatest gift and the source of life itself. Luckily for us, Neely became interested in water about 10 years ago and now shares with us Water Stories, Conversations in Paint and Sound, an exhibit about the most critical issue of our time. Anne's paintings show us water in many aspects, and the audioscapes designed by sound artist Halsey Bergand reveal thoughts and experiences of water that people around the world have had. The exhibit lures us in with its beauty, but is also disquieting because we sense that something is not right. To help us understand the larger context of the exhibit and the global significance of water stories, we are fortunate tonight to have Professor Shafiqul Islam. Shafiq, as he is called, will underscore our water situation and some actionable steps we can each take. First, to lead us on her journey making water stories, please join me in welcoming artist Anne Neely. Good luck.
Good evening, and thank you all for coming. Such a wonderful moment to see all these familiar faces. It's great, thank you. First of all, I'd like to thank David Rabkin, who is the Director and of Current Science and Technology. It was David who I went to with my ideas about water, and the two of us shared this vision. It was wonderful. And I also would like to thank Lisa Monroe, and she is the program manager for special programs and events and lectures. And we have Lisa to thank for this part of the lovely evening. So thank you, Lisa. I want to start by telling you I'm going to tell my story, how I got involved with water, and then I'm going to tell you a little bit about the ways in which I paint and the ways in which I use paint to tell that story. I've always been intrigued by wonder. Wonder to me is the gateway to the mysterious. And I think that between science and art, this is the way in which scientists and artists collide in a similar way into their studies and into their ways of communicating to the world. I think of scientists as looking at mystery and trying to solve problems. And I think of artists, like myself, looking at mystery and trying to reveal it in my art and in other artists' art. And so there are lots of questions that are asked, and I think that is the beauty of both of our crafts, science and art, is that we ask those questions. I think that one of the first things I can tell you about my story is that 10 years ago, I was handed a book by Jack Bousman, and that book was called Water Stories by Marc de Villiers. Marc de Villiers wrote this book in the year 2000. It's called Water, the Fate of Our Most Precious Resource. And in that book, he just spoke of things that I had never heard of before, global things that were happening, changes to rivers and streams and oceans, and it was extraordinary. I'm actually going to give you a quote of one of the things that he wrote that really just shook me. Water has become imperiled, not through the deliberate actions of evil people, but through the small doings of many, far too many, ordinary people, doing things the way they have always done them. That's where the danger lies. So this was something that was so profound to me and made me think about the way I use water, the way water is used. And I started thinking about some of the terms that he used, like the word aquifer. In 2004, I didn't know what an aquifer was. An aquifer, for some of you who might not know, is an underground layer of permeable soil and rock and sediment bearing water. Well, that idea just captivated my imagination, and I proceeded to think about what it would be like to paint something like an aquifer. I continued to paint things about water for several years, and during that time, I began to use titles for my exhibitions like Just the Elements, or Where There's Water, or What the Weather Brings, or Water Lines. I was inspired to think about those titles and those exhibitions as having some effect. But at the same time, I realized that I was just dealing with the art world, and the art world, although wonderful, is in many ways teaching to the converted. And so even at that point, I really wanted to stretch a little bit further to find further avenues and different settings for my work. I wanted to tell you about I want to tell you about this painting. Now, it's on in my screen, but not on there. So, well, I can begin the story while Kyle is working on this, and that is, I was in the summer of 2010. I was in my studio in Maine, way down east, almost to the maritime provinces, and I was there painting a big, large brown area, and then with the deepest blue underneath it. And this was my idea of there we go. This was my idea of an aquifer. And an old Mainer came in and said, "Why, that's Mopang." And I didn't know what he was talking about. And I asked him, what was he talking about? What is all this news about Mopang? And he then proceeded to tell me the story of Mopang Lake and Mopang Aquifer, which is under the lake, which is in Township 30, which is about 45 miles from where I live. And he said how a developer came to the town of Machias and requested to build a toxic ash dump right next to the lake. And he figured that no one would care, and it was so far away, and it was in the middle of nowhere that it wouldn't be a problem. Well, the citizens in that area got together, and they decided that it was going to be a problem because all of the rivers and streams fed into our water sources in that whole area. So it was really going to be a problem. And they gathered together and formed in 1989 the Clean Water Coalition. And that organization raised money, went to court, fought this developer, and won the right to have Mopang be free, clear, and clean. That to me was such a powerful story. It was about action. It was about what people did to make something that was unseen protected. That was powerful. So in my mind, making something like Mopang was a beginning of a way to access that world of aquifers being threatened. I also kept thinking that it was something that I wanted to do. I wanted to go further, and the teacher part of me felt that there was something educational in making paintings about water. I feel that painting, in many ways, intrinsically has this learning muscle that can be tapped. And it deals with the way in which paint is put on the canvas, the way in which the textures of paint, the way in which paint holds memory, holds emotion, holds intellectual perceptions and perspectives. It also shows time and scale shifts. There's just something very powerful about the way paintings become a language. And so I really wanted to find a new place to do that. Hence, David. David came into my world. I called him up and said, you thought about water lately? Can we get together? And certainly he had some ideas. He limited the exhibition, thank goodness, to the United States, and we picked 4 issues that were part of the issues that we were dealing with. And then, since the first story that I heard of really was this story, of my own story rather, of Mopang, I thought that was such a powerful story that I wanted to have other stories from other people. So I started traveling and actually interviewed about 200 people, and then I gave them all the interviews to Halsey Bergand, and he created a sound component that is just extraordinary. It's stunning. He's very masterful in doing that. And he's a sound artist, and he took some of the questions that I had asked the interviewers and then got them to and put them into various different tracks, which when you go into the exhibition, you will hear those different tracks. I want to just skip over to something that I read the other day in the newspaper, which underscores one of the most important things that I feel is happening with the issues around climate change and contamination and pollution and the misuse of water and water mining. And that is Robert Stavins, the professor and the director of the Environmental and Economic Program at the Kennedy School at Harvard, talked about, he had an op-ed in Sunday's paper a few weeks ago, and he said, climate change is essentially unobservable by the public. On a daily basis, we observe weather, but not climate. And I think that's so telling. It's like everything that we are dealing with around water is so unseen and just so neglected and so ignored that was just a very powerful piece that he said. He continued to talk about what was going to happen in the next 50 years and how the floods were going to rise and the sea level was going to rise and islands were going to disappear and we would have great disease. And this is one of the paintings that is in the show, and it is my own interpretation of, the flood that would not stop. The impending foreboding. I'm going to quickly talk about my experience as a painter. I think I have just a few minutes left to talk about that. I start by making a pour, and this is the beginning of a pour. I mix up colors, and I physically pour the colors onto the canvas. And a pour is like being, if any of you are runners, it's like being in the zone or being inside music, as much as I can describe it. It's an extraordinary experience. I take the canvas and I move it in various different directions, and I attempt to make some sense of it all. And as I am doing it, I have various different, as you can see, various different expressions and moments of great tension and then release and wonderful happiness at some moment where I feel like the pour is the beginning of a conversation, which is a questioning always in my mind. So then when the paint gets to the point of, blending all together, then I let it dry. And the process of the pour, I look at it for a long time and just see what it tells me, what it calls me to respond to. In many ways, the random or that part of the painting is now over, and now I become much more intentional. And I think about some of the things that I've been thinking about with water, and I start very purposefully layering intentional mark making on top of curiosity and randomness. I think the whole visual language follows a thread of thought, and the one idea is built on another. I use very basic elements like you can see here. You can see that I use elements like circles and squares and rectangles and everything that is central and essential to nature. Thank you, Cezanne. He did that as well. And I have a sense that Cezanne backed up into science as well. Anyway, I use the marks to create an infrastructure. It's terribly important to me to build layer upon layer. And I think about all the infinitesimal forms that are in the world of water that were in balance and now are not. And so I begin to think about that, and with that, my imagination comes alive as I build these layers. So I think to myself, what else would you like to know? I guess the last thing I will say is that painting is a very, very visceral experience for me. It records how I feel about the world that I live in, and it helps me to make sense of it. It gives me the opportunity to create some sort of meaning in my life. Because I really do believe that we do live and we only have the world around us and the present and the memories that we hold. And so what I would wish for you is that perhaps each of us could become stewards of the planet, and that we would be more conscious of the situation around water and to cherish it. Thank you so much.
So thank you, Anne, for a wonderful finishing slide, Cherish Water. But before I begin, I would like to thank the organizer really for bringing me here. On my website, I have a first sentence, this water is all I think and do. And that is, I think, is very well connected to what we are trying to do today here is art meets science. So you think, and then you have to also do it. And how do you combine these two has been the struggle for me for last, how many years, I would not tell me, anywhere between 25 to 40 years. So what I will try to do today is to bring you to the actual water, but is it a resource or is it a right? Today is a wonderful night to talk about water. It's raining outside. Where does this rain come from? Is it really raining the water that has evaporated from Boston, or did it come from Brazil or from the Nile? We do not know. It's a global cycle, so water can evaporate from one part of the world and it can rain anywhere. So who does it belong to? So if you follow a particular water particle, when it evaporates from the ocean, it's public property. When it rains on Quabbin Reservoir, that where we get our water for Boston, it is still public property. Then it comes to the pipes, we clean it up, and it comes to your home, we buy it, it becomes private. Then again, when I use it, abuse it, and discharges, it goes to Boston Harbor, it again becomes public. So this private-public, so it's a very strange combination really. At what point you intervene water will have very serious implications. And that's what the problem is. The amount of water that we have today has not changed since the time of dinosaurs. But now we are 7 billion of us. We argue whether fish has more right than farmers. Is urban development more important than agriculture? Is hydropower more important than fish? So there are all kinds of complicated questions comes in when there is a limited resource. What we are arguing that water is not limited. We need to think about water differently. Water can be very flexible. The water that I use today for taking a shower, tomorrow you can use it for growing tomatoes. So it can be multiplied in multiple ways. And to take a very outrageous example, I really do not have any shortage of water. The problem is most of the water is salty. So if somehow I can figure out really how to desal the water, we have no problem with water. So with energy, sun is giving us lots of energy, we just cannot convert it to right form. Of course, there are environmental consequences. There are other issues involved, but in terms of actual availability, there is no shortage, neither for energy nor for water. But there are physical constraints, there are technological constraints, and we'll get into this in a second. What's happening, Kyle? It doesn't move. Maybe it needs you. All right. Yeah, I think that's the problem. So this is a picture for the Nile Basin. The reason I'm putting this in really is I will be in Kenya really this Monday. So on the Nile Basin Development Forums. So Nile is a basin that crosses 10 different countries. But Nile was there for 3,000 years ago. At that time, there was no boundary. Now, if you look at really here right now, we have 10 different countries that share Nile. In 1920s, British decided that Egypt should get most of the water in the Nile. Although Egypt has 2 inches of rain per year. Most of the rain happens in Ethiopia and Sudan. So that was given as an international right to Egypt in 20s. Now Ethiopia thinks, no, they don't have the right because it rains in Egypt, in Ethiopia or in Sudan, so water belongs to us. The argument that I was trying to make, if it rains in Boston, does it belong to us or it belongs to someone else? Because water cycle is global. So that creates a conflict. And that conflict has been going on for many years. This is part of the reason this on Monday. So many countries and many heads of the states are coming to see really what can be done about the Nile Basin water sharing. So we have some ideas really how to share this water. So we were invited to give a talk, and I'll talk about with the story. So the story is about this, about 3,000 years old. It came from the Middle East. It's about camels. So there was a wealthy man, and before he was almost going to die, so he had 3 sons. He decided that, look, sons, I have something for you. I have some camels. The first son will get half of the camel. Second one will get 1/6, and the third one will get 1/9 of the camel. And after I die, please share it among brothers and be good. So that happened. So father died, and then brothers tried to figure it out what to do. There are 17 camels. I cannot divide it by 2, cannot divide by 6, cannot divide by 9. So it's a mathematically unsolvable problem. What can we do? One thing we could do, kill all the camels and distribute the meat. That will be a nice scientific engineering solution, and it will be fair. But then, of course, that's not the purpose of the camel. So they said, no, maybe something else is going on. But they could not agree what to do. So fighting started amongst brothers. Cousins are not talking. Families are basically in serious problem. They just simply could not come to an agreement. Then they thought, what should we do? Then they found out that there is a wise lady in the next village. So they went to that lady. So say, look, we have a problem. We want to respect our father's wish, but we simply cannot do it. Can you help us? She said, look, this seems like a very difficult problem. And I really don't have a solution right now. Why don't you come back in the morning? Let me think about it over the night, and I'll see what I can do. So next morning, the brothers again went. The lady said that, look, I cannot solve it. But I have an idea. I have a camel. I'll give it to you. Take it with you and see whether you can do anything about this. So that's the camel she gave. So they thought, wow, this is a very strange lady. She seems to be very generous, so let's take it. So why not? We have made now one more camel to take it with us, and they did. While going back, they found out that something really strange happened. Now they can start dividing it. So they have 18 camels. So they divided by half, 9. First brother gets 9. Second brother gets 6. And the third brother gets 2. So it was very nicely divided. I still have a camel left. They said, wow, this lady is really genius. And so she figured out really, and so this is the 18th camel that we are looking for. What is that 18th camel? That really does not exist right now. So it is a mathematically unsolvable problem. I have limited amount of water resources that I cannot distribute among multiple sectors. Water, food, energy, everything is competing for water. How do I create that 18th camel? That is exactly the message. So this is what we're trying to promote also in the Nile Basin on Monday. So this is also what we want to think about when we talk about limited resources, then we get into fight. And that has been the human history. When the resource is limited, uses are many, you fight. Unless you can come up with a creative option of 18th camel. So what is that 18th camel will depend on the context, and we'll talk about a few of these really as we go along. So So this is the 18th camel we're looking for. Now, this is the framework that we have developed, what we call this, that ultimately the conflict really is between two domains. One domain is the natural domain, where we talk about water quality, water quantity, and ecosystem. These are fairly well understood. You go into science, engineering, they can do this. Another domain is what we call the societal domain, where we have ideas of governance, assets, and norms and values. And these are two different domains of knowledge that has been developed over the last 200 years in water. So you go to economists, they will say, water is an economic good. And then you talk to someone else, they said, no, this is not a good, really, it is a right. So is water a property or a right? These are all very difficult questions. On the other hand, really, when I talk about water in terms of quality, quantity, these are more scientific objects that we can think about it. But that's not the problem, really. We have pretty good understanding how to do this in the natural domain and the societal domain. But things really happen in a politically real world. So politics is continuously speeding these processes. As a result, we have politics in the middle. So what is going on really, you have three different systems coupling with each other, and it's not clear exactly what is important. And that makes water problems very complex. And there is no really clear solution to this problem. If I want to tell you that, okay, fine, you have 10 cubic meter of water, it can be done. But when you talk about really whether I can displace 10,000 people to bring in water to Boston, that's exactly what we did. When we built Quabbin Reservoir in 1920s, what was the reason? The Boston was growing too fast. It simply cannot sustain itself. It needs more water. So what do? We go to Quabbin, about 50 miles from here, eliminate 4 cities. Make the largest reservoir that was done in 1920s. Did we have the right to eliminate those 4 cities, really? Those are the question was not asked at that time. It will be very difficult to do it now. But it has been going on in many parts of the world right now as well. So this is another picture really that was taken from the satellite. This was a reservoir on the Nile River, close to Sudan. When you see it from the sky, it looks like so they're filling up the reservoir to create some hydropower. What it misses though, by filling the reservoir, you have also displaced several thousand people. You have eliminated a lot of archaeological evidence. Those are not evident in the picture. So that is exactly what is going on. In the picture, you see certain things, although it looks basically pretty bad, but even hidden pictures are more important. And where basically those things happen, the art could be very powerful to bring in those hidden pictures that Anne was referring to. Really, there are a lot of hidden things go in water, because water is very vital as a resource, as well as a right, as a property, because most of us really, even physically, are water. If you think about it, really, the Indian Prime Minister is visiting right now. If you follow the story, he's fasting. For 9 days, he's not taking any food except water. So he cannot survive without water. So water is very vital. Without food, he can survive for 9 days, and he's being very active and very functional, but he needs to still drink water. So that is why the water is very vital. Water, although it's a renewable resource, it is the resource that is fundamental to even our existence. So this is being developed now in the Nile Basin. So Nile Basin is using a lot of water from the groundwaters that Anne was telling about aquifer. So aquifer is very deep in this Africa. So you have to use a lot of energy to bring that water up. But then you can still develop some agriculture. This is the agriculture field in part of the Nile Basin. And we have done the same thing here also in the US. This is Ogallala in the US. Because we are smarter and the water is closer to the ground, we have virtually over-exhausted Ogallala. We have taken out as much water as we could and put in fertilizers so that we could be extremely productive. That was very necessary because we have been basically growing up to 7 billion. We needed more food. So how did we create more food? We exhausted water from the aquifer. We've used nitrogen, phosphorus. That has created more food for us, but it also created something else. What it did really, so if you look at these two side by side, one is the Nile, another is Kansas. Kansas is very well developed. Do we want that to happen in Africa also? If we do, really, what can happen? So those are the type of questions we need to resolve. So this is what will happen. So this is Lake Erie, algal bloom. So algal bloom happens because we are using a lot of nitrogen and phosphorus. It goes into the lake and creates significant algal bloom. So are we trying to make this, really, if we want to go and do this in the Nile Basin, this is exactly what would happen. Are we ready for it? But at the same time, we would also ask, really, do we have enough food to feed everyone? So these are very difficult questions to resolve, really. That cannot be simply yes or no. If you look at the actual fertilizer use, what you see really in Africa, really, they're not doing very much, really. So it's very low. Africa can be like Europe. If you start producing more food by putting more fertilizer, we can grow more food. But then there are environmental consequences. So is there a trade-off between these two, and how strong those trade-offs are? These questions are not scientific questions. These questions are questions of values and norms. And that simply cannot be decided by scientific objects. That's where we say that these need public participation. Public as a whole has to decide. The people who are affected, they need to decide. Precisely for that reason, in our water diplomacy frameworks, I work as an engineer with people from social science and negotiation, that who are the people at stake. I'm going to the Nile, but for me, the stakes are very low. The people who live in the Nile Basin, for them, stakes are very high. So they need to understand, and they need to know really what the stakes are and what are the scientific solutions are, what the uncertainties are, what will climate change do. That's where the science could be powerful, but science cannot give you the answer. The answer has to come from the people who will get affected by it. So that brings us to really, what can we do right now? So what can we do really is, so first one we put, of course, our own website is the water diplomacy. What we are arguing that we need to think about water differently. Differently meaning that we have two simple ideas, that water is a flexible resource, meaning that I can create flexibility of water depending on the context. For example, if I need more water for Boston, can I use desal? For example, like if you look at all the restrooms here in the Museum of Science, they have now a very interesting flash. One for your liquid waste, another for solid waste. So you can use different types of water. 20 years ago, we used to use 3 gallons per flush. Right now, we use less than a gallon. So that means we have become smarter. So we use less water now for the same purpose. We can also use economic instruments. We can hike the price of water. So there are many ways you can create flexibility in water. So that is first thing that we need to do. Second one is that we want to create this 18th camel. I mean, what are those creative options that we can create for a given situation? And that 18th camel will change from situation to situation. If we can create this 18th camel, then we have a solution that is sustainable. And that is what we are trying to do, this what we call the Aquapedia case study, where we are trying to bring case studies from all over the world, because most of the water knowledge are not scientific knowledge. These are the knowledge that you need from indigenous people, from the people who have been using it for the last 3,000 years. They know exactly what to do. Sitting here, trying to reproduce, for example, what is happening in the Tennessee Valley Authority or in Ogallala and trying to transport it to India, we create a disaster. We tried to basically reproduce Ogallala aquifer in India. Of course, we increased the rice production, but created serious environmental consequences. So we don't want to make the same mistakes in Africa. So what we want to do really, we want to find out contextual solutions. And those contextual solutions are not really very easy science. So these need to be done contextually. That's the reason we're trying to develop a database where people can give these ideas of different experiences. Then you tie those with science and find out a solution. That is what I call wisdom. It's not really just pure yes-no answers, because many of these questions will not have yes-no answers. They will have wise answers. And those wise answers can come really from this synthesis of art and science. And that's what we're arguing in Aquapedia. So there are MIT Science Collaborative is another initiative that is in town that you can get involved. Charles Water Riverside Association, another one is at your back door. We're trying to protect Charles River. It's a small river. It is our river. How do you make it more sustainable? And then if you really want to get involved, then you can basically go to our website and then look at multiple things that we are doing, 4 different things, and then can get involved. Even more actively is that if you really want to do something today, you can do this. So there is an app. I think it is already for Android, maybe not for iPhone yet. WeTap.org. So you can find out the closest place where you have public water supply, so that I don't have to buy bottled water. I saw that the bottled water was a place. So you don't have to buy bottled water. You can put it basically, okay, this close to Museum of Science, there is a public water supply. So somebody can come and fill it up. So that's what I tell in my class. And in my class, bringing in plastic bottle is illegal. If you bring it, you lose points. So you can bring your knowledge in, but not really bottled water. Because the water is much cheaper, because last time I checked, really, I pay $3 per 1,000 gallons of water. If you go to now any of the places, Starbucks or Dunkin' Donuts, $1.69 per liter. That translates to $7 per gallon. Last time we checked, the gas is still $3 per gallon. So I'm paying $7 per gallon of water, where actually at my home I am paying $3 per 1,000 gallons. So somebody is making a lot of money. The question is basically at this cost of environment. So we have to be careful. So this is the first one that we can do. The second one is the Aquabadia case study I talked about. And then if you really are not happy with the first two, you can go to many, many projects if you go to scieStarter.com. And there are many projects which are water related and you can get involved. And with that, I'll stop. Thank you.